To understand language, the AI first breaks it down into tokens and then complex embeddings.
All right, welcome to The Explainer. Today, we're going to peel back the curtain on AI. We're going to find out how it actually understands what we're saying. It's this wild journey from our language into the mind of a machine.
So think about it. You use AI all the time, right? We type something in, it spits something out. But how? I mean, a computer at its heart just gets numbers, zeros and ones. So how on earth does it bridge that gap? How does it make sense of our words? Okay, to figure this out, we're going to follow a single prompt on its journey. We'll see it from the second we type it, all the way to how the machine finally sees it.
So here's our guinea pig. Let's say we type this in. Write an email apologizing to Sarah for the tragic gardening mishap. You know, something we might actually write. To us, that's a perfectly clear request. But for the AI, that sentence is a puzzle, and it's got to solve it before it can even think about writing that email.
So the very first thing the AI does, it's not thinking, it's chopping. Yeah, chopping. Before it can process anything, it has to break our prompt down into these smaller, more manageable pieces. And this whole process has a name, tokenization.
So just picture our sentence, the one about the gardening mishap, getting fed into this machine, that nice, clean request. It gets totally fractured. It's not one single thought anymore. Instead, it becomes this collection of individual parts. And boom, here's what's left after that chopping is done. See anything kind of weird? Some words like right and an are left totally whole. But look at others. Apologizing gets split into apolog and izing. Even the period at the very end gets its own little box. So these little chunks, they're called tokens. And honestly, the best way to think about them is like Lego bricks, but for language. They're the absolute fundamental building blocks that a large language model uses to read, to understand, and eventually to write text back to us. But, and this is a really important but, not every AI uses the same Lego set. The way a model decides to chop up words is actually a huge design choice. And different AIs, they do it in totally different ways. Okay, get this. Just take the word capitalization. An older model, something like BERT, splits it into capital and this weird little fragment, #ization. But a newer, more advanced model like GPT-4, it might see it as capital and ization. It's a tiny difference, but it tells you so much about how each of these models was built to see the world. And this idea of specialization becomes super obvious when you start comparing different models. You've got BERT, which is kind of like a generalist. It ignores capital letters. It doesn't even know what to do with emojis. Then you have GPT-4, which is amazing with code, so it knows that programming words should be single units. And then there's something like StarCoder 2, a total code specialist, which actually breaks numbers down digit by digit so it can get better at doing math. The tokenizer is always tailored to the AI's specific job. Okay, so where do we go from here? Our prompt is now a sequence of tokens. The AI's next move is another act of translation. It's going to turn these little bits of text into the one language that all computers speak. Right, so remember these? We started with a nice, clean sequence of tokens, something that we as humans can still easily read and understand. But this is what the language model actually sees. It's not words anymore, not at all. It's just a list of numbers. Every single token, whether it was apolog or izing, has been swapped out for a unique ID number from the AI's enormous internal dictionary. It's basically a giant lookup table. And these numbers? This is the only language the machine really gets. So this basically breaks it all down. Our words become tokens, the tokens get a number. But then there's this third step, and this is where the magic really happens. Each of those numbers isn't just a label. Nope, it's a key that unlocks this super rich, complex mathematical map of what that token actually means. And this meaning vector, it has a special name. It's called an embedding. You can think of it like the AI's own personal Rosetta Stone. It's the key that translates a simple number ID into a really deep mathematical understanding of what that word means and how it relates to everything else. So at its core, an embedding is just a list of numbers, a vector. But it's a very, very special list. The cool part is that tokens with similar meanings, like, say, king and queen, will have lists of numbers that are mathematically very similar. And that's how an AI can start to grasp these really abstract concepts like royalty or gender or power, all through math. Okay, now this idea is so incredibly powerful that it goes way beyond just text. Some researchers had this brilliant idea. What if we used the exact same logic for music? And here's how they pulled it off. They decided to treat every single song like it was a token, and every playlist someone made as a sentence. By looking at millions and millions of these playlists, they were able to create an embedding, a meaning vector for every song out there. And the result? Well, songs that people tend to put in the same playlists end up having very, very similar mathematical meanings. The power of this is just mind-blowing, really. When the researchers asked the system to find songs with embeddings similar to Metallica's Fade to Black, what did it find? Van Halen, Dio, Guns N' Roses? The system knew absolutely nothing about genres like hard rock or heavy metal, but just by understanding the context of all those playlists, it learned the vibe. It understood the song's meaning, purely through math. Okay, so we've been on this whole journey, right? From our words to these little tokens to numbers, and finally to meaning. So what's the big takeaway? What's the one thing you should really remember from all this? It's this process, this quiet, completely invisible transformation. It's the absolute foundation of all modern AI. I mean, every single time you ask an AI to write code, or summarize a long article, or even just have a simple chat, this is the journey your words are taking, behind the scenes. At the end of the day, understanding tokens and embeddings, it's not just some nerdy technical detail. It's really about understanding the very first, most crucial step in how we teach machines to communicate with us. It's the bridge that connects our messy, beautiful world of language to their clean, logical world of numbers. And that leaves us with a final thought to chew on. We've seen how this works for language and for music. So if we can represent these incredibly complex human things as just patterns of numbers, what else can be? What other parts of our world are just sitting there waiting to be understood as a vector?